So in this video, we're going to go through a couple of examples, again, making sure that we have these ideas set in our head. So again, we're talking about modular arithmetic here. So for this example, example 3, what I'm looking to do is I have the congruence class of 1234, and this is modulo 5. I want to be able to simplify this. So off to my whiteboard here. So exercise or example 3. I want to be able to simplify this, so I have 1234. And again, this is all mod 5, and I want to be able to simplify this out. Now, there's a number of different ways of being able to do this. So remember, when I'm dividing by something, my congruence classes are made up of the remainders when I divide by that specific n. So when I'm dividing by 5, my possible choices are going to be 0, 1, 2, 3, and 4. It's what my remainders can be when, again, divided by 5. So if I'm thinking of, I have 1234, if I divide that by 5, what am I going to get? Now, you might see right away that the 1230, not the 34, but 30, is divisible by 5, which means all of that is going to disappear, and what we're going to be left with is the 4, and 4 is one of the remainders. So this is a perfectly acceptable way of doing it. Now, if you can't see this, let's expand this out using all the techniques that we developed in the last set of videos. So first thing I'm going to do, I'm going to start off here, 1234. I'm not going to do the subscript of 5 because, again, we know what we're dealing with here. So what I'm going to do is I'm going to expand the 1234. So this is 1 times 10 to the 3, so that's going to get me my 1,000, plus 2 times 10 squared, so that'll get me my 200, plus 3 times 10 to the power 1, so that'll get me my 30, and then plus 4. And again, using the properties from the last theorems, we could break this up. So I can rewrite this as the congruence class of 1 times the congruence class of 10 to the power 3, plus the congruence class of 2 times the congruence class of 10 squared, plus the congruence class of 3 times the congruence class of 10 to the 1, I'm just going to leave that 1 out, plus the congruence class of 4. Now, one thing to note is that the congruence class of 10 is the same as the congruence class of 5, which is the same as the congruence class of 0. And we can see this if I look at the difference between 0 and 10. Well, it has 10 units in between it. Well, that's a multiple of 5. So that means 10 is congruent to 0 mod 5. Again, that distance between the two has to be a multiple of our n. Our n in this case is 5, so it gives me that this is equal to the congruence class of 0. So if I do that substitute in, well, this is going to get me a 0. This is going to get me a 0. This is going to get me a 0. So my first 3 terms are all going to be 0. What am I left with? I'm left with 4. And that's my final answer. So again, we could have seen this right away by knowing that the 1230 is in fact divisible by 5. So that's just going to get me 0. And then what am I left with? I'm left with just the 4. So there we go. Let's move on to another one. So example 4, we want to calculate the cube of 51 modulo 7. So I want to take 51 cubed, but I'm doing this mod 7. So back to my whiteboard here. Example 4. So I have 51 cubed. Again, this is mod 7. Now I know, again, from all of my theorems that I had before, I could rewrite this as 51 cubed. Now the idea of being able to simplify this, I want to simplify my bigger numbers here. So if I look at 51, well, what is the remainder of 51 when I divide by 7? Well, when I divide by 7, I'm going to get a remainder 2, and I can see this as, if I do 7 times 7, that's going to get me 49, plus 2, that's going to get me my 51 cubed. Now my 7 times 7, again, modulo 7, that's going to disappear, so this just leaves me with 2. 2 cubed. All right, now 2 cubed, that's easy. That's going to get me an 8. But 8's greater than 7. So again, by modular arithmetic, I have to put this into its right class. So what is 8 mod 7? Well, 8 mod 7, again, if I divide 8 by 7, I'm going to have a remainder of 1. So this means this is equal to the congruence class of 1. So that's a lot easier than taking 51 cubed and then trying to do this out. At least I think it's a little bit easier than trying to do it that way. All right, and last one here. Example 5, I want to simplify 7 to the 100 modulo 6. So 7 to the 1,000, sorry, or 100, not 1,000, modulo 6. Wouldn't matter if it's to the 1,000 or the 100. It's gonna, the calculation is just gonna be as easy. So the first thing I want to do, whoops, that 6 should not be there. It's not a exponent, it's a subscript for being mod 6. So the first thing I want to do is I want to break this up into 2 parts. So the congruence class of 7 to the power 100, again, this is mod 6. Okay, but 7 is greater than 6. So if I divide 7 by 6, what's my remainder? Well, my remainder is 1. So the congruence class of 7 is equal to the congruence class of 1. And again, we can see that those two classes are equal because if I look at the distance between 7 and 1, that's 6 units. Again, that's a multiple of 6, so these hold true. Now I have 1 to the 100, which, as I said, it doesn't matter if it's 100 or if it's 1,000, it's still going to be 1 in the end because this is just 1 to the 100 or 1. There we go, 3 examples. We'll see you back here at the next lesson.